Okay, everybody, in this video, we're going to be looking at measuring temperature and pressure as related to gases. So what we want to first look at is how to measure temperature. And one of the scales you're very comfortable with is the Celsius scale. We're very comfortable because we use it in everyday weather. And we know that at the Celsius scale, the melting point of water is 0 degrees Celsius. Boiling point of water is 100 degrees Celsius. We also know something else. The lowest possible temperature is something called absolute zero, and it happens at minus 273 degrees Celsius. That's very cold. Now, when we're doing calculations, scientists, we don't want to worry about positive and negative values. So we have another scale that scientists have developed. It's called the Kelvin scale. It's exactly the same as the Celsius scale. The only difference is the zero is shifted 273 degrees. So instead of having absolute zero at minus 273, absolute zero is actually zero on the Kelvin scale. And then the melting point of water, instead of zero, is 273. So to get the Kelvin scale temperature, the Kelvin temperature, all you do is you take the Celsius temperature and you add 273 to that. And similarly, if I want to go the other way, I want to go from the Kelvin to degrees Celsius scale, I subtract 273. So a quick way to remember is that the degrees Celsius is equal to Kelvin minus 273. So I'm bringing this over, it becomes negative, and there's my little formula there. We also have to worry about pressure when it comes to gases. And one of the earliest ways to measure gases was developed by Evangelista Torricelli. He had a dish of mercury, and what he did is he had also the mercury here in the dish was connected to mercury in a glass tube. And what he noticed was that the pressure of the atmosphere varied slightly. But what it did was it pushed down on the mercury here in the dish, pushing the mercury up inside of a column here. And at sea level, the air column, or the column of mercury, sorry, was pushed upwards 760 millimeters. So we say that standard pressure conditions, sea level, would be 760 millimeters of mercury. And we also can use the unit torr in honor of Torricelli, but these are exactly the same. They're just a different way of measuring mercury. We can also measure pressure in terms of atmospheres and in kPa. And what you notice is that at 1 atmosphere, we've got 760 millimeters of mercury, which is 760 torr. That's equal to 101.325 kPa, and it's the same as set 14.7 psi in the old system. So these are all equivalent to each other, and we can convert back and forth whenever we have to, depending on how we're measuring pressure. So one thing we have to keep in mind is we have to keep conditions constant when we're measuring gases, because if I change the temperature or pressure, I can dramatically change the volume, and that will change the amount of gas that I'm adding in a reaction. So it's important to keep things consistent. So scientists have developed a system called standard temperature and pressure, where we have standard atmospheric pressure of 1 atmosphere, and we say that the temperature is 0 degrees Celsius. So we have standard temperature and again standard pressure. There are a variety of ways we can record the standard pressure. We also have something else called standard ambient temperature and pressure. This one's a little bit more close to the laboratory environment, where the temperature is 25 degrees Celsius instead of 0 degrees Celsius, so it's a little bit easier to compare. We're going to focus on standard temperature and pressure, STP. Now, in order to understand standard temperature and pressure, we also have to be able to do some basic conversions. So what I have here is in your workbook. You're going to have some conversions that are going to be involving temperature. You're going to be involving some conversions involving pressure. Let's quickly review temperature. So when it comes to temperature, remember we're going to have our Kelvin scale, and the Kelvin scale is equal to the degrees Celsius plus 273. And if I want to convert the other way, the Kelvin minus 273 is going to give me my degrees Celsius. So what I'd like you to do is I'd like you to try these two conversions here, and pause the video right now and then check your answers in a minute. Okay, let's see how you did. So for the first one here, I've got my Kelvin is what I want. So I'm going to take I'm going to take the degrees Celsius, 15 degrees Celsius, and I'm going to add 273. So when I do that, I'm going to end up with 288 Kelvin. So that's the equivalent here. If you want to, we should also be rounding to significant digits. It's 292 significant digits. Now, if I want to go from 320 Kelvin to degrees Celsius, all we do is we take the 320 Kelvin. This time we subtract the 273, and we end up with 47 degrees Celsius as my answer. So fairly straightforward. Now, when it comes to pressure, things get a little bit more complicated because there's more ways we can measure the pressure. So remember, at 1 atmosphere, we can measure pressure at 1 atmosphere or 760 millimeters of mercury. We can also use 760 torr. We can also say that the pressure is equal to 101.325 kPa, or even PSI, 14.7 pounds per square inch. These are all equivalent to each other, and what we can do is we can make a factor label conversion associated with these over here. So I'll go through the first one, but then I'd like you to try some of the other ones on your own. So what we have here is got 3.00 PSI. I'm going to change it into kilopascals. So I'm going to write down my pressure in PSI, and then use a conversion factor. So I'm going to be looking at what I'm doing here. I'm going from PSI to kPa. I look at the equivalent. So know that 14.7 PSI is equal to 101.325 kPa. And what happens is the units over here are going to cancel. And we do a little bit of math over here. So it'd be 3 times 103.25 over 14.7, and we end up with around 20.7 kPa at the end of the day. So 3 times 103.25 divided by 14.7. So try the other conversions here. Use the factor label method, and be careful with significant digits at the end. So pause the video and see how you do in a bit. Okay, let's see how you did. So what we have here for the first conversion is we had 249 kilopascals, and we change them into torr. So I know that there are 101.3 kPa in 760 torr. So I write down my conversion factor, the kPa at the bottom, so the units cancel. You multiply 249 times 760, divide by 101.3, end up with 1868 torr. Now we only had 3 significant digits at the beginning. I have to make sure I only have 3 at the end, so I do a little bit of rounding, end up with 1870 torr. For the next one, 0.5 atmospheres. We know that 1 atmosphere is 101.3 kPa. We basically set up the conversion factor, units cancel. We end up with 50.65 kPa. But remember, 3 significant digits, I have to have 3 significant digits at the end. The next one is very similar. We have our millimeters of mercury. I know that 760 millimeters of mercury is equal to an atmosphere. Set up the conversion so the units cancel. You end up with 0.895 atmospheres. So this is very, very important that you guys can do these types of conversions. Make sure you know the ones that I expect you to memorize. There are certain ones. Other ones I will have posted on a test for you. Take care, guys. Bye.